Alright guys, let's talk about graphing lines. So we're going to use the equation of a line to find the intercept and slope and then make the graph. And normally that will be the x-intercept. And we'll talk more about that in a second. So I want to start off looking at this example from our last assignment. So we had this list of values. If there are 2 dogs, there would be 13 cats. If there are 3 dogs, there are 17 cats. 4 dogs would be 21 cats. If there's 5 dogs, there's 25 cats. And we took those and made this graph, dogs being across here, cats being up here, and 2 dogs was 13 cats, and those are those 4 points right there. And then we filled in the rest of the line, showing based on the number of dogs how many cats. And along with that, the rate of change was 4 because it's going up 4 dogs for every 1 cat, up 4 cats for every 1 dog, up 4 cats for 1 dog, up 4 cats for 1 dog. So that is the rate of change. The initial value is 5 because that's where it starts. If there are no dogs, there's 4 cats. And this is the equation that would go with that. D equals 4C plus 5. D is how many dogs, C is the number of cats. And of course, that equation only works when D is not negative, because you can't have a negative number of dogs. That's why this line didn't continue down that way. Okay, so what I wanted you to notice from this example that we did last time is if we started out with this equation, we could tell 4 is the rate of change and 5 is the intercept. So instead of finding this line and graphing it using those points, if we had this equation, we could start by saying 5 is the initial value. So when D is 0, it's got to be 5 and get that point right there. And then 4 is the rate of change, so we go up 4 over 1, up 4 over 1, because that's the rate of change. 4 cats for 1 dog, 4 cats and 1 dog, 4 cats and 1 dog. Okay, so in this blank on your notes worksheet at the top, I'm gonna say we could have just used the initial value, which was the 5, and the rate of change. Okay, if we know those 2 things, that can tell us the whole line. Okay, so what we're going to focus mainly on today is this thing called slope-intercept form, which you've probably heard of before. And in order to use slope and y-intercept, we must have the equation in slope-intercept form. And that looks like this. Y equals a number times x plus a number. Okay? Y equals some number times x plus a number. And that m and b could be any number. It could be 3, -4, whatever. So where m and b are numbers, m is the rate of change, or on a graph, we would call that the slope. And B is the initial value, or also called the starting value, or on a graph, the y-intercept. So on this graph, 5 was the y-intercept because that's where it crosses the y-axis. Okay. So let's do an example really quick here. Y equals, and make sure you get all that real quick, to our example. So y equals 2x minus 5. We'll start with this, minus 5. B equals negative 5. So the y-intercept is negative 5. That means it will go through the point negative 5, 0. Oh, my bad. It's x comma y. So 0, negative 5. 0, negative 5. So this is the x-axis. This is the y-axis. So when x is 0, y is negative 5. Right there. It's the y-intercept. That means it's crossing or intercepting the y-axis. And then we'll find more points using the slope. Okay, the slope is 2. I'm going to use a different color for the slope part. M is 2. So that means we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And you can see how that's going. I'll use a straight edge or ruler, make this nice and straight. And there's the line. So we got some more slope-intercept examples on the back. Okay, 4x minus 7. So B is negative 7. That means we're going to cross through it, label the x and y axes here. So y being negative 7, 1, 2, 3, 4, 5, 6, 7. Okay. And that is 0, negative 7, point-wise. Then we'll go at a rate of change of 4. That means we're going up 4 over 1, up 4 over 1, up 4 over 1. You sometimes hear that called the rise over the run, or change in y over change in x. So 4 is really 4 over 1, so we got up 4 over 1, up 4 over 1. And fill that in. There's our line. And if you try plugging exact numbers for x in here to check the points, you will get the same thing. Okay, this one, B is 2, so we'll go through right there. And M is 1/3. So what we're going to do is go up 1 over 3. You could go up a third over 1, up a third over 1, but I think it's easier just go up 1 over 3, up 1 over 3. And we'll connect those. There we go. All right. So then the question is, what if you get a line equation that is not written in point-slope form? Like, what if it looks like this? That's not y equals something times x plus something. You can plug in numbers and calculate and plot of individual points. So just what if x is 1, and then solve that and find what y would be. What if x is 2, and then solve that for y. Kind of goes a long way. Or you can do it the easy way and just change the equation into slope intercept form. Okay, so let me show you what I mean. Slope intercept form is y equals mx plus b. So what we want to do to get this into slope intercept form is get y all by itself. I want to get y all by itself here. So first thing I'm going to do is subtract 6 from both sides. So 2y plus 0 equals 5x minus 6. Or we could just say 2y equals 5x minus 6. Now I want to divide both sides of that by 2. So that will be 2 divided by 2. It will just leave us 1y. 5x divided by 2 would be 5/2 x. And negative 6 divided by 2 would be negative 3. So plus negative 3, or you could just say minus 3. So we have y equals 5/2 x minus 3. So why did I do all that? Because I wanted to make it look like this. So I took away the pieces that were on the side with the y to get y equals the rest of this stuff. And it's easier to get rid of this 6 first instead of divide by 2 first, but you could divide by 2 first. It doesn't matter. Okay, so now that we've got it into slope intercept form, we can plot the intercept. B is negative 3, m is 5/2. So now we're just going to go up 5 over 2. Up 1, 2, 3, 4, 5 over 2. We go down 5 and back 2. And we'll connect those guys all together. And we've got our line. Okay. We'll do a couple more examples like that real fast. This one, all we've got to do is subtract 7 from both sides, and we've got it in slope intercept form. slope intercept form. Okay, so that one we'll graph real fast. -7 will be down 4, 5, 6, 7, and then the slope is 3. So I'll go up 3 over 1, up 3 over 1. And make my line. Okay. B. This one will take a couple more steps. First, we've got to use the distributive property. Now we can get rid of the stuff that's with y. First, I'll subtract 6 from both sides. And get 2y plus 0 equals x minus 6. 2y equals x minus 6. And then I'll divide both sides by 2 and get 1y, or just y, equals x over 2, or I could say 1/2 x, minus 6 over 2 is 3, or negative 6 over 2 is negative 3. So for that one, we will have a y-intercept -3. We'll come down here, y-intercept -3, and then the slope is 1/2. So I'm going to be going up 1 over 2, up 1 over 2. And then I'll just connect that all together and have my line. Okay. Last two examples. I'll just do these really quickly for you. +1, +1. 3x plus 1 equals 2y. Divide both sides by 2. We have 3/2 x plus 1/2 equals y. Or if you want to make it look more like y equals mx plus b, we can switch the sides there. Y equals 3/2 x plus 1/2. So the slope would be 3/2, and the y-intercept would be 1/2. So start at 1/2 and go up 3 over 2. Up 3 over 2. We'd be really careful here. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, and this one, subtract 2x from both sides to get the y's all by themselves. 3y equals -2x plus 6. Those will add to 0. And then this side we got that. Now divide both sides by 3. And get y equals -2/3 x plus 6 divided by 3 is 2. So we'll start down here at 2 and go down 2 over 3. Down 2 over 3. there. And that is the line for D. This one was B. This one was A. This one was C. Okay. Last little section. Sorry, this video is going a little bit longer than I was wanting. But the question is, should you just always put it into point slope form so that you can graph it? A linear equation can always be put into point slope form. So if you're not sure, just do that. Put it into point slope form so it looks like y equals mx plus b, and you can always use that and figure out the line, what the line will look like on the graph from that. But sometimes there's an easier shortcut way of doing it. Shortcut. So I'll show you, this is part D from that last page, the blue line right here. There's actually a way you could get that line without doing this work and changing it first. So I'll just show you that really quick. First you say, what if x is 0? If x is 0, 2 times x is 0, and you just have 3y equals 6. So if x is 0, y would have to be 2, because 3 times 2 is 6. Okay, so we found a point 0, 2, which actually is the y-intercept. But then what you do is, instead of saying what if x is 0, you say what if y is 0. If y is 0, then 3 times 0 is 0, so this whole part will be gone, and you'll just have 2x equals 6. 2 times what number is 6? 2 times 3 is 6. So if y is 0, x has to be 3. And put that point there, and then we can connect those 2 points and get our line. And that's a little less work than completely changing the equation and then going off of the slope and the y-intercept. So we'll learn a little more about this and one other type of form for linear equations next time. So these are the three ways that linear equations can be written specially. And so we've learned this one now and talked a little bit about that one. We'll finish up this one and learn about this last one next time. So thanks for watching and see you next time.